Welcome to the Dynamic Learning Hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank ExcelR for being a part of it.
Good evening, all. Students, kindly inform your friends to join the session as soon as possible. Okay, we will start for the day. Shashank, sir, good evening.
Good evening, ma'am.
Yeah, sir, you can start the sessions.
Sure. Okay. So, good evening, everyone. So, welcome to day 13 of our session. We have 2 more days to go, apart from today's session. So, let me share my screen. Okay. In the last few days, at least last 3 days, I can say, we have seen a lot of practical part. Some tough concepts as well, I would say. Yeah, because there are some of the tough concepts involved in that practical part as well. So continuing from that, let us talk about a few theoretical concepts as well today. Okay, because some of the applications, some of the things which we are using in the generative AI. So let us talk about those things today. Okay, so coming from those practical part. Now, the first important thing I just want to explain for today's session is what is webhooks and APIs. Okay, so this is a very important part. One of the important concepts. Okay, so what are webhooks and what is APIs? Okay, so basically APIs, you might be knowing that what is an API. So API is nothing but the application interface. Okay, so to display this particular APIs into what we are kindly or sorry, what we are currently using is basically the connective part or the connecting part is what we call as webhooks. Okay, so let us first see what is an API, then we'll come back to this picture. Okay, and we will see one more picture as well, and we'll try to understand from there, and we'll let us take it over from there. Okay, so just give me a minute. Okay, so if you have any questions, you can just post it in the chat. Okay, right. Okay, so first let us see what is agent communication. Okay, so there are two important things when it comes to agent communication. The first one is the API and the other one is the webhooks. Okay, so we have seen in bit, I would say some 3 or 4 sessions back, we have seen what are AI agents, what is agentic AI, and all those things. We have seen some of the basic things in practical as well as some theoretical aspects as well. So now coming to the aspect of what is agent communication. So the first important thing is how first we have to understand first what is an agent communication. Okay, the first important thing is what is an agent, right? So we already know what are agents. So agent is nothing but something which can do a certain task, okay, on a certain one particular with some goal. Okay, you can say that a person, it's actually a programmed software, right? Now if you see what is agent communication, we can see that agents need to communicate with the other external systems. So this is not a new thing we are seeing now. So in our previous examples also, we have seen a few things, because the agent communicating with the other agents is very important, right, to perform a certain tasks. All right. So for that, there are, to communicate like this, there are two important things. One is the APIs and the other is the webhooks. So now talking about the APIs, so application programming interface is what the API is about. Now, what is exactly API? Okay, so what is exactly API in, to understand what is this API is about? They are basically nothing but a set of rules and regulations. Okay, so what we are writing as a program, okay, we can say it is set of rules, it is set of logics, right? It is kind of a reasoning aspect. You can say anything when we talk about API. Now, how does it work? Okay, so how does this actually work? Is basically the agent will make the request. Okay, so agent will make the request and the receiver will send the data. Okay, so it will retrieve or send the data. So that is what we are going to do. For example, in a particular software you're using, you can think of a particular software you're using. So you're requesting something, right? So you will request it, right? So how that will be retrieved? So that will be retrieved through the request what you have given in that particular application. Okay, so that is what this interface is basically about. That means you are asking to retrieve something. Okay, so in that way, these particular APIs or the agents communicate inside the APIs, because APIs have agents inside, correct? No, so they have agents inside. These agents, give you or give you a solution for the whatever request you have actually made. So in the a very simple use case I have taken here. So a weather agent query open weather map. Okay, so you're asking for the weather, right? So you're asking for a weather for a particular location, all right? So you can think of that it is basically you're using a API. Okay, so what are the pros for this? So it is secure and standard. So obviously all the applications are actually all the applications, many of you are Android users, are iPhone users, or even you would have seen the usage of applications in Windows as well. You have seen in multiple places, correct? So you have seen in multiple places. So all these multiple places, you have seen the application being used as well. Okay, so these are basically secure and standard, and they can handle multiple request response. For example, if you are using one particular application, your friend or your somebody might be also using, right? So that is not saying that no 10 people are using this, I cannot respond. It is not like that, correct? It is actually responding for how many interactions or how many requests are actually given. So all of them it is able to handle, right? So that is what the specialty of APIs. So it can handle multiple responses. And the next thing is it is widely supported, right? So widely supported indicates in multiple locations or multiple platforms. Okay, you can think of on multiple locations as well as platforms. Okay, so coming to the cons, it is typically synchronous and may require polling for updates. So sometimes to update a particular application, there might be some of the practical problems as well. It has to be tested in all the applications, then only the updates can be given. So that is one con which you can face. Now, so let us see how does this API works. So basically these APIs, everybody, you guys are aware of, right? So already you will be seeing this in action in your mobile phone as well. So you are not new for these applications, correct? Now, you want a particular request or you have a certain request in your application. Okay, so you request the API, right? From there, it actually connects to the web server. Okay, from there, it connects to the database. Okay, and then you will get the response. Okay, from the response from the database. Then you will get it to the end user, right? From the application, you are going to get to the end user. This is a simple, I would say it's a very simple way to understand what exactly is an API. Okay. Now, let us see what is a webhook. Okay, so I think a few of you would have been already aware of what is a API. So it's not a new thing, you'll be saying. So, but there is also one more concept, which is called as a webhook. in agent communication, which is the webhook. Okay, so what are these webhooks? Okay, so these webhooks are basically a one single, or you can say, a small sentence to, or a small way to describe these webhooks is event-driven callbacks. Okay, event-driven callbacks is a very simple way to understand what is a webhook. So what is this exactly is going to do? Okay, so something which gets triggered, okay, by a certain event. So for example, if you want to trigger a particular alert, right? When something actually happens, okay, so that at that particular scenario, you can use a webhook. Okay, so for example, like a Slack bot receiving a webhook when a user sends a message. Okay, so for example, like you're using a bot. Okay, so if you send a particular message, the bot responds, right? So it is basically a webhook because something which is getting triggered. Okay, so that is basically a webhook. Okay, so in the simple terms, so the agent setups a URL endpoint and external systems push the data to it when events occur. So that is what you can define as a definition for webhooks. So the pros are basically the real-time updates, efficient, all right, and cons are requires exposed endpoint, harder to debug than APIs. So you can see this problem to webhooks, or even the APIs as well. When these things actually happen is, I'll tell you one scenario. So if you see, these practical problems occurring for particularly if you see Android phones. Okay, I'll tell you a very easy example because you might be aware of, because most of you you will be using an Android phone. So if you see here, there is a certain thing in Android phones, right? The updates you'll be getting, right? For example, it might be an application, okay, not the software updates from the, I would say, the company. Okay, let us not go there. Okay, so that is bit, at a higher level. Yeah, at a higher level. So let us not go there. I would say we can think of an example like, maybe in Play Store will update. Okay, so sometimes you will see that there might be an issue with the application, correct? So it might be crashing, or after the update, the application might not work properly. So these kinds of problems you might be seeing, right? We are not getting that. I would say we are not getting that frequently now in the current generation, but few years down the line, if you see, these used to be the problems. So the situation or the scenario for happening of this is basically the problem of not testing in the devices. Okay, so not testing the properly in that particular APIs and not using the webhooks properly. Okay, so this is what the scenarios can actually be. Okay, so that is why the testings will actually be done in all the I would say different kinds of mobiles as well. Okay, so usually now they are doing on the chipsets as well. So automatically, most probably it might not create any problem. Sorry, it might not create any problem for the end user. Okay, so that kind of examples you can think of, because these applications and webhooks are kind of interrelated, and these are basically used for agent communication. So in this way, you can try to understand what are these webhooks and agents. Now, one more simple example is webhook in an chatbot. For example, when you talk about a chatbot, okay, so usually what happens, the first thing is the customer sends in a request, right? So basically the customer sends in a request. After that, the chatbot, if it can resolve, sorry, if it cannot resolve, most probably a chatbot cannot resolve. I'll tell you why, because I think we have covered this difference also, chatbot and virtual assistant. So this is not a new thing we are learning. Actually, we have covered in our session as well. So chatbot is nothing but a basic of some set of rules. Okay, so it has some set of rules. So what happens is, if something is beyond its set of rules, it will not be able to solve that problem. But a virtual assistant is not like that. So a virtual assistant, what it does is it will search the web. Okay, so it will search the web and it will give you a particular solution for a particular problem. Okay, so virtual assistants like Google Assistant, Siri, right? All these are virtual assistants basically. But a chatbot is a basic, we would say it's a basic set of rules. Okay. Yeah, it is basically, just a basic set of rules. Okay. So that is what a chatbot is. So usually what happens is, you cannot expect a chatbot to resolve your problem. Okay, so it can resolve only if it is inside that set of rules. Okay, and I don't think so. Usually the customers will ask a easy or a problem, something which I would say a chatbot actually can solve. That doesn't happen actually in reality. So usually what happens, it sends to a webhook. Okay, so it sends it sends the request to the webhook. Okay, so at that position, the support system will actually try to function. Okay, and from there it raises a ticket. Okay, and actually a support agent will function, whether it is actually a support agent, whether it might be an AI support agent or it is an actual person. Okay. Yeah. So it might be an actual person as well. So after that, it comes back to the support system. Okay. And this support system sends to webhook about the CRM, notifying about the new issue. Okay. Because the customer relationship management is also very important to know to know about the problem, what has actually arisen. From there, it come back to the support system, and then the customer problem will be actually resolved. Okay, so this is what exactly the webhooks actually do. So it will raise that particular request to that support system. So this is basically done by a webhook. Okay, so that is why along with APIs, even the webhooks are very important. So going to the next part, I think by this time you would have already understood what is the difference between a webhook and a API. So webhooks, what are they basically? So webhooks helps in sending alerts, messages from the server side application to the client side application. So exactly what are APIs now? So APIs help in passing the request from the client to the server application and then delivering the information. So now APIs are nothing but just it is like a delivery agent. So sending the request, okay, after getting the request from the customer and sending that request and getting the details for that particular request is what the job of an API. But webhook is something where it will alert or it will trigger, okay, and it will get the solution from the client side. Okay, so from it creates that alert. And when is a request mode? Oh, sorry, when is a request made? Okay, so this is the next question between to understand the differences. So webhooks receives calls through HTTP posts from the external systems only when they are data updates. So something which has an updates only, this will be receiving the HTTP posts. Now coming to the APIs place requests without knowing if there will be a data update on a request or not. Okay, so this is a big minus when it comes to the APIs. Next is when to use each. Webhooks are ideal for when the application or the app demands real-time updates. Okay, so something is demanding a real-time updates, you can use the webhooks. Okay, so next is APIs. APIs are ideal to use when there is a constant change in the server-side application. Okay, so next is how do they work? So webhooks are automated calls that get triggered when an event occurs on the server-side application. So the next thing is APIs. Basically, these are used for adding, editing, deleting a set of items after being instructed by the client-side application. Okay, so whatever we have discussed in differences, you can see. So let us move to the next thing. Okay, so the next thing is factors to consider when choosing APIs and webhooks. Okay, so these are some of the factors where you can understand. So one is the communication type. Okay, so then is a latency, then security requirements, complexity, level of control, and data volume. So these are the parameters in where which will help you, or these are some of the scenarios, I would say 6 scenarios where it will help you to think or consider that it will make you to think whether you have to use a API or a webhook in a certain scenario. So yeah, so webhooks, yeah, so events happen, sends the data, so processes automatically. A few images I have added so that you'll be having some clarity to understand what is a API and a webhook. Yeah. So yeah, so application, yeah, API is actually easy for you to understand. Webhook, it might be a bit tricky. So now it might be a bit clear for you when it comes to a webhook. Okay, so now, so this is actually a full picture of how a webhook is actually connected. Okay, yeah, I thought this might be useful for you as well. Okay, so from the user, yeah, we send a message to the agent. From there, the message will be received by your webhook, and it will think that what kind of response it has to give. Okay, the agent will has to give which kind of response. Okay, so that will come back as a response. So that is basically a webhook. Fine. So let us go to the next concept. Okay, so enough on webhook and APIs. It's a very important concept. So yeah, I thought of touching that as well. So now going to the next thing, which is the decision making, which is rule-based versus learning-based. Okay, and the first thing is rule-based agents, right? So basically the first one for the rule-based agent is the logic. Okay, so for the rule-based agent, it is basically explicitly programmed rules. Okay, so it is just a if-else conditions. So it's just it's just a set of rules and regulations, okay, to obtain certain thing. Okay, so a very easy example to understand what is a rule-based agent, a chatbot that responds with pre-written answers based on a keyword detection. So you can think of as a rule-based. So predictable and transparent because for a certain questions you will get the same answers from the chatbot. Okay, because it's a rule-based, it's just following that set of rules and regulations what we have given. Okay, so next is easy to implement for simple tasks, and the limitations are poor adaptability, can't learn from the new data. So next thing is the components of a rule-based system. So now let us see what is the knowledge, base. Okay, so the first, components of rule-based. The first one is the knowledge base. Okay, so knowledge base KB is not a new thing. It is like a repository where the all kinds of statements, sentences, logic, right, all are basically saved. Okay, Next comes the inference engine. So how the inference is actually generated from a certain sentences, right? What conclusions can be made. Then how all these are actually made or used is what the user interface is. Then the rule editor, which kind of rule based or which kind of rule is being basically used to apply a certain things. So then comes the rule interpreter. So after applying a certain rules, what interpretations can be made from that? Then the explanation module, where once a certain thing has been done, what is the possible explanation or what is the probable solution, right? How it is actually came to that particular conclusion that this is the only solution, this is the solution which is actually obtained. So this will be identified by the explanation module. Now, going to the next thing is the learning agents. Okay, so let us talk about the learning agents. So talking about the learning agents, the logic is the usage of the machine learning to make decisions based on data. Okay, so that is very important. Then the example is a recommendation agent that improves over time by learning user preferences. Okay, so the advantages here is adaptable and scalable, and can generalize to unseen conditions as well. That is where the the machine learning models come into the picture. So the next thing is the limitations, harder to interpret, requires data training and evaluation. So which AI system to use? Okay, so that is very important because we are discussing about the generative AI part. So here you can see the first thing is the rule based. So this is basically out of picture, or I would say out of from what we are trying to implement in the generative AI part. So the rule based nothing is but a set of rules or set of rigid rules and regulations. So this doesn't have the adaptability. This actually lacks the adaptability part. So next thing is the LLMs. So LLMs are something where it is flexible, semantic networks, and also provides a user relationship. So LLM is nothing but large language models. Then we have something called as a hybrid model, which is basically a combination of both the rule-based as well as the learning capabilities. So these are the four important things which you have to see the difference between the rule-based as well as a learning-based agents. Okay, so the first one is adaptability. So that is very low when it comes to rule-based agents. Okay, for learning agents, it is very high, right? So adapting is very high for the learning agents. Then transparency is high for the rule-based because it's just some rules and regulations. Okay, so it is easy to transparently see what is going to happen. It is medium to low when it comes to learning agents because they will think on its own and generate. So we cannot actually predict the transparency. So data requirement, it is none for the rule based because it is just some rules and regulations. We are not fixing any data or we are not providing any data. But for the learning agent, since it is based upon machine learning models, it is very important that we provide data for building of learning agents. So next is the setup complexity. So it is basically high inside the learning agent, but it is relatively low compared to the rule-based agents. Yeah. Now, the next part is rule-based versus LLM-based AI agents. Okay, so this is a very important comparison. Okay, when it comes to the rule-based versus the LLM models. Okay, so now before going into this, if you have any doubts, you can just put it in the chat. Okay, we just put it in the chat. Yeah. I'll just wait for a couple of minutes. If I get no questions, I'll just move forward. So if you have anything, please you can ping it in the chat. Last 4 5 days, actually, not much questions about either you're understanding everything or you're not understanding anything. So one should be true. So I've taking on a positive note, I feel you're understanding everything. So that's why you're not asking any question. I feel, I hope. Yeah. Okay. I think no questions. Probably I think we can continue. Okay, good. Fine. Okay. So let me continue with the the differences between the rule-based versus the LLM-based AI agents. Okay. So the first and the foremost important thing here is the operation, right? And the first thing is the operation. So basically, these rule-based are predefined rules, right? So which is actually based upon reasoning, logic, and all these things. Okay. So, but the LLM based is basically understanding the patterns in the data, right? So based on that, it is actually generating the responses. So the next thing is the decision process. So it is basically the same, okay, because it is just the set of predefined rules and regulations. And for the LLM models, it is basically a probabilistic response, or you can think of it is like a you would say it is like a training and testing. So the chances of or the outcomes will be a probabilistic natured outcomes. So the next thing is the flexibility. So limited to predefined cases cannot handle unknown inputs. Okay, but the flexibility here is can adapt dynamically to various types of input. So handling different kinds of input is very important. They are basically more flexible. So next thing is complexity handling. So this basically struggles with ambiguity and unstructured data. So this is basically excels in processing complex and nuanced information. So next is scalability. So it becomes difficult to scale as the number of rules and regulations, or you can say rules grow. So easily scales to handle large data because the models for the LLM-based AI agents basically are having that capability. I would say are having that capability to handle the huge amount of data. Okay, so that is why we are using them in the first place. Okay, so next is transparency, highly transparent and easy to bug. Opaque decision-making process often seen as a black box. So sometimes it will be very difficult to bug. Okay, but coming to the rule-based agent, it is very easy to bug because it is just some rules and regulations. So bugging is basically extremely easy. So next is the learning ability. So no learning, static rules must be manually updated. Okay, so can be trained on additional data to improve the performance. Okay, so the next thing is computational requirements. Low does not require intensive processing power. High requires advanced hardware and infrastructure. So the use cases are form validation, compliance checking, rule-based chatbots. So conversational AI, content generation, AI powered virtual assistants is what the use cases are. So now let me go to the next one. Yeah. So now the next important thing we are going to talk is about the goal formulation. Okay. So let us talk about the goal formulation. So what is a goal? Okay. So what is basically a goal? So goal is nothing but achieving something. One certain task which has to be achieved is basically a goal. So for example, if a user actually says book a flight, okay, so the assistant or the AI agent, right, or the virtual assistant, it has to call that particular or it has to check the schedule where it has to book correctly. So when you are exactly traveling, right, and what is your budget and how much of money you want to spend, right? So on a certain things, it will take information from you and it will contact that particular service provider, and it will try to book a flight in your name based on the budget you have provided. So it has a certain goal that it has to book a flight for you. Okay, so for that it is going to do or follow some certain tasks in order to execute. Okay, so that is the main aim of using the goal formulation. So the next thing is, what are the 7 steps to actually set up a goal? Okay, actually to set up a goal. So the 7 steps which actually are used to implement is nothing but figure out your goals. That is the first one. And write your own goals down. Consider how you'll measure your goals. Prepare for potential obstacles. Map out a timeline and create a plan and monitor the progress. This is how actually we set up the goals. Correct, no? Now, how we have to set it up or how we have to give it for an AI agent. Okay, so how this formulation will be done in an agentic AI or AI agents. Okay, so the very important thing is the it starts with the object identification. Okay, then goal specification. Okay, so this object identification will be the first part. Then it goes to the goal specification. Then it is setting criteria, right, and environmental assessment, then planning the action, and then further planning. Okay, so each particular thing has again subdivisions in it, right? Particularly coming to the objective identification, you can see that prioritization, feasibility study are the 2 sub important features inside the object identification. So the next after that is the goal specification. We have SMART goals and the resource allocation in the goal specification. Then after that, we have setting criteria. Here we have the performance metrics as well as the quality standards, right? And then environmental assessment, data collection and analysis is the important thing in it. Then we have planning actions, action steps and timeline development. Then the further planning, where the contingency planning and review and adjustment is basically done. Now, let us see the architecture of using a goal inside an AI agent. So the first thing is inputting the goal, which is the goal interface, right? So user goals and system triggers. Then the orchestral planning. Okay, that means a lean decision engine. Then cost carbon capability triangle, workflow and task assignment, right? From there, it will go to the third step, which is the specialized lean agents. Okay, so there we have data retrieval, analysis part, action execution, Q&A, and applying the custom agent. Then from there, it is go to the fourth part, which is the tool of the API layer. We have seen about API, no? Yeah, that is why I have explained about API and webhooks before going into the this goal architecture or goal-based agent. Now here we have external interfaces and execution. And then the fifth step, it is going to go to the shared state, which is catching, relevance filtering, multi-agent synchronous. Okay, synchrony. Then the sixth step is basically the monitoring, resource tracking, human in the loop, performance feedback. Then the feedback is the feedback loop continues until the feedback is a positive. Then it comes to the seventh part or the seventh step, which is the output and the action interface, which is basically delivering the results or the output. So this is the whole process of the agentic AI or the AI agents, based on this, what we are actually talking, goal formulation. Okay. Yeah. So let us go to the task execution. Okay. So I just given a glimpse of what is a task execution as well. So after basically we set up a goal, the agent must plan and act, right? So for that, it will try to plan each request. So I've actually given you an example of booking a flight. Okay. So booking a flight is not a entire, it's just a goal. Okay. It is not a planning part and an execution part, right? So it has to check your calendar where you want to book the flight, right? It has to understand that what is your budget, right? And okay, probably you would have already said, give me this budget, give me this airlines. Still it has to check the dates with the airlines as well, correct? Whether the seat is available, right? So all these things play a very important role while executing the tasks. So now, how should the AI system basically adapt its goals and actions? This is very important. Now, the three important things are the probabilistic reasoning, the update distributions, and the reassess the after the diagnosis. Okay. Now we will see each one in detail. So the first one is the probabilistic reasoning. So this basically involves the uncertainty in the data. So we all know that what is this? What is basically probability means? So probability is nothing but a uncertainty in the data. So the next thing is the update distributions, where the choice of focusing on refining predictions with new evidence. Okay, because probability is something where you're not 100% certain. So basically, this update distributions are getting new evidences to support your basically the claim. Next thing is reassessing the diagnosis, where basically it is applying for the adaptations, processing to improve accuracy in specific context like the medical diagnosis. Now talking about the agentic AI, right? So what are the important steps which are actually performed when we are setting up the goal? So the first thing in the goal orientation, we have the objective setting and the task execution. Now, to execute this, we need a tool, right? So the tool is basically using calculators, web searches, APIs, applications, right? So multiple areas it is going to use the tool. From there, it is planning and reasoning. Then it is going to the core intelligence of applying the LLM models. Okay. And then it is going to the memory systems. So whether has to use a short-term memory or a long-term memory. From there, it is going to the self-improvement. So like this step-by-step approach is going to happen, where an AI system should perform a certain goal, okay, or execute a certain goal. Okay, so coming to the next part, the guide to integrating the goal, or I would say integrating your strategy, okay, for a certain execution. Now, the first thing is the encouraging the adoption of data analysis. Then we have identify your use cases. then select the areas of opportunity, then audit your capabilities, then narrow down your choices, implement a pilot project and a small scale, then establish a baseline understanding, then scale your AI integration, complete the AI integration, then build and implement and improve. This is how these strategies will be there to build a goal-based agent, which can actually also perform the tasks and executions for us. Okay, this is how the companies actually build them. Okay. Now, okay, yeah. So I just wanted to send this one before itself. Okay, so let us talk about the examples of the APIs and webhooks. Okay, yeah. Now, I just kept it later only because I just wanted to first discuss about the APIs and webhooks. From there, I just wanted to go to the goal-based. Then let us now come to the applications. Okay, yeah. Now you'll be in a better position to understand that what are these applications and how or what are these goals, okay, and how they are actually doing it. Now, okay, some of them are, might look simple for you to understand, okay, but on the whole, this is how the AI systems or the AI agents are actually functioning, okay. So the first example is the food delivery bot. It's basically an application, okay. So now it is like a Zomato or a Swiggy, what you're trying to order, what you're trying to use to order food, okay. So sometimes you might use a chatbot, okay, or if you're not using a chatbot also, you're using the API, which is the application. So in the API, you are fetching the restaurants, right? After that, you are placing the order. Then you are tracking to get the order. Now here, what happens in the background is agent acts as an interface between the user and the backend services. This is the job of AI agent, which you cannot see, right? But there is an agent functioning in the background process. So this is how you can see the new food delivering machines which are actually performing. Okay, so you might be seeing in applications, right? In India, I think we are not using this, but a lot of countries have implemented using this food delivery agents. Okay, so you can see that's these are the food delivery robots which are actually functioning. Okay, yeah. So these are basically the food delivery robots. Okay, so they have that where to deliver, right? So what is the product it is taking? Okay, so the route, the map it will have, just like how the delivery agent you are seeing kind of right now, who is coming to your home to actually deliver your food. Okay, it is very similar to the kind of delivery agent who is coming to your house. Okay, but here in this case, but in this case, it is actually a robot. Okay. Now, second thing is webhook for a DevOps agent. Okay, so probably you might have heard about GitHub. Okay, so basically GitHub is a repository. Okay, so this GitHub webhook for DevOps agent. Now here you can see agent. DevOps is nothing but development operations. Okay, so here you'll be having a webhook, particularly and I would say a trigger, right, which you can actually use it. So this basically triggers for pipelining when a particular event actually occurs. So GitHub sends a web post request to an agent server when new code is actually pushed. So agent reacts instantly by starting, build, test, and deploy. So deploying is nothing but sending the project into the real world. Okay, so for this GitHub webhook, you can see one example is Jenkins. Okay, so Jenkins is one such example or application Okay, in a DevOps project. So this is an example. So Django is nothing but a Python framework. Okay. So basically, this Jenkins fellow is actually I would say, he's like an agent. Yeah, let us say he's an agent between the developer and the Amazon company, an application. Okay. So in between we have GitHub, Docker, Jenkins is there. Then it comes to the AWS EC2. AWS is Amazon Web Services. Okay, so this is how an AI agent can actually perform and function. Okay, so this is how a webhook will be there. So here there something just happened. Okay, now let us go to the third example, which is decision making based upon rule based and learning agents. Okay, so here we have a scenario. So customer support chatbot. Okay, so a telecom company chatbots answering her billing questions. So the scenario is yeah. So what is the rule? If the message contains bill plus not received, show bill download link. Okay, so if the message has network plus issue, provide troubleshoot options. Okay, pros is instant and predictable. Limitation is cannot understand natural variations like my internet bill being weirdly late. Okay, so these kinds of questions it will not be able to understand because it is a rule based. Okay, so it is not, it doesn't have that learning ability or understanding ability. Okay, so yeah, so anyway, we are aware of what is a chatbot. Okay, so we cannot, yeah, if you might have forgot about a chatbot because we have already discussed what is a chatbot and a virtual assistant. So it might be refreshing your memory also. Okay, so that is why I just put here the benefits of using a chatbot. They are basically fast. That is one one positive thing of using a chatbot. Okay, but it has its limitations also. It is its response is basically limited. Okay, and the cost is also very less and effective to build a chatbot rather than building a, I would say, rather than building a virtual assistant. Okay, so 24/7 availability will be there, and so on. So there are some of the benefits from which you can use a chatbot. So this is an AI chatbot. So AI chatbot can think on its own and it can answer the questions in a multiple ways. But a rule-based chatbot cannot do that. Okay. Yeah. So you can see an example of how a rule-based and a learning agent can actually function. Okay. So rule-based will just go with the rule. It will not understand what you have actually given. Okay. So this is the difference. Yeah. So one more example. So this example is very easy to understand for you. How an AI-powered chatbot functions from a rule-based chatbot. Okay, so this is one more example where you can understand. Yeah, so we'll stop here. If you have any questions, you can just pick. We just go for a short break. Okay, so you can just let me know if you have any questions before going to the break. Okay, so you can just let me know if you have any questions. You can just ping in the chat. So we'll see from the Netflix example after the break. So you can just ping me if you have any questions. So after that, if you don't have any, then we'll go for a break. Okay, then. Okay. So no questions I got during the break. I just posted nothing. So let me share the screen. Let us continue from what we are doing. Okay. Great. So let us continue on that. I think it's fine from your end. Okay, fine. So let us talk about the next example, which is the Netflix recommendation systems. So this is definitely not a rule-based agent, right? So this is definitely a learning-based agent. Okay. So what this will, basically do is it will try to suggest. Okay. So a certain, since we're talking about Netflix, so basically what is a Netflix? It basically suggests the content based on the content you have watched. Okay. So or you have the content you have rated or you have skipped, right? Not for me, you have liked. So all the different kinds of things what you have, it is going to learn, right? The machine learning models are going to learn from what you have actually done. Okay. From there, it is going to, try to recommend, right? The content for you for a more personalized experience. Okay, so agents get better with usage and personalized content over the time. So here how it is going to happen. Okay, so in a simple terms, how this is going to happen. So we all know that this is going to happen. Okay, but how this will actually happen is what this example, so this image actually tells you. So a user, user agent, what it does is basically implicit. Okay, the input he is giving, right? Now, when he actually interacts, okay, with the agent, here it is going to create a machine learning algorithm. So the machine learning algorithm uses a repository. Okay. So what is that repository? It is the repository called the SQL database and the cache memory. So from this SQL database, which is the database for all the movies, okay, it is going to update to the activity agent. From there, the interaction will happen. Okay, and the user will get the recommendations. So this is how the process actually moves on. Okay, yeah. So I think you can see it in the picture. Okay. Now going to the next part, that how the system here. This is one more example of, you can see how it actually happens. Okay, so you rate, your behavior is seen, your queries will be identified, because you will be searching for movies also, no? You remember? Yeah. So your restrictions of attributes will be observed. So all these will be analyzed, collaborated analysis, direct query. So your behavior, your analysis of ratings. So everything will be observed, which will be, built as a model, right? And it will communicate with the databases. From there, you will get as a recommendation systems. So this is the process. This is a cycle which is going to happen. So watched by both users, right? So if it is watched, a particular content, it is basically suggested to, okay. It is not like each person will be sitting and analyzed. So basically one particular TV show, right, it is mostly watched by, so similar kind of genre TV shows or movies will be suggested to the users. So this is how the recommendation systems actually work in real time. So next is the goal formulation and task execution example. So Google Assistant booking a table. Okay. So let us see an example of how the user actually gives the query or one particular goal for the AI agent. Okay. So he says book a table for 2 at 7 p.m. at the Fatty Bow. Okay. So it's a restaurant. Now, what will happen is it will understand your intent. Okay, so it will understand that you want to book a table first. So it will look up for the restaurant in the Google map because you have given the word Fatty Bow. So it will look up in the Google Maps and it will check the availability. Okay, so what it will do is it actually calls that particular restaurant because it looks up in the Google, right? So it has a phone number. You would have observed, right? There will be a mobile number or it might be an email. So if there is no mobile number, it will email that particular, that particular hotel saying that I am Google Assistant. I want to book for my client, I want to book a table. This is the features I want. So if you are basically having a phone number, so it will call and tell that it is a Google Assistant. Okay, and it wants to book a table. This is the request from your client or the master. Okay, and it will take the confirmation and then it will reserve the table and then it will send a confirmation SMS. Okay, you will receive the confirmation SMS from the hotel, as well as it will send a confirmation SMS or an email to you stating that it has booked. More of a trigger. Okay, that the table is actually booked. So this is the process of how basically this how this Google Assistants or any virtual assistants actually work. So based on the goal, it will execute a certain task. Okay, so you can see from this example. So the restaurant owner will be getting a call stating that, hi, I'm Google Assistant calling to make a reservation for a client. Okay, it will tell that it is a Google Assistant. Okay, it will not say that I'm a human being. I just want to, sorry, it doesn't tell, it doesn't, it doesn't use your name. Okay, it's not, the virtual assistant is not trained like that. Okay, so it is safe. It will say that it is a Google Assistant. It is going to reserve for a client. Okay, yeah. So this is how you're using the Google Assistant. So booking appointments for your businesses. Yeah. So this is one more example you can see. I just put a few things so that you can link up. So probably you would have tried this, you would have done this. Okay, yeah. Next is the smart home agent. Okay, so what are these smart home agents? Okay, so these smart home agents is something where it controls everything in the house. So this is basically a multi-agent system. These smart home agents are a classical example of a multi-agent system. So here what is happening is there are multiple agents which are performing or which are functioning together. So here if you see that there are, when you say make the room comfortable, there is multiple agents working here. For example, one agent is a light sensor. One agent adjusts the AC. Okay, so one agent, does something else. For example, put on a light, nice, cool melody music. Okay, so basically it's just applying an AC, but if you add something like that, play something to make more comfortable, the atmosphere more comfortable. So that also adds up to something which you want to add. So if you see here, there are multiple agents which are performing inside. Okay, so that is how you can relate to multiple agents performing. So this is basically a definition of a smart home. So something which is connected to the internet, IoT devices, and they can be remotely controlled. Okay, so you might be seeing this. Okay, so here even more creative example where you can see that how things work. So right from the alarm system, temperature controls, keyless entries, motion detections, controlled irrigations, controlled appliances, lightning control, smartphone alerts, energy management, right? So many things are there, to call a home a smart home basically, because there are a lot of aspects to it as well, correct? No? So a lot of things which are involved. Now, let us go to the next part, which is the types of interactions. Okay, so here we have three types of interactions. One is the cooperative agents, competitive agents, and mixed motive agents. Right, so we will see each and every one in detail. Okay, so the first one is the cooperative agents. Okay, so this is actually a part of MAS. MAS is nothing but multi-agent system. Okay, so the first one is the cooperative agent. So here we are seeing a definition of what is a cooperative agent. So agents that work together to achieve a common goal. So this is basically a cooperative agent. So the behavior of these is shared knowledge, divide the task, and synchronize the efforts. So a real life example for this is self-driving delivery vehicles. We have seen that like a delivery agents, right? So food delivery agents and all, right? So multiple vehicles work together to deliver the packages across the city. So they share the real-time traffic data, route data to avoid overlaps and delays. One vehicle might take over a delivery if another breaks down. So these are some of the real-life examples which you can think of when it comes to the cooperative agents. So going to the next one, which is the competitive agent. So here you can see that what is a competitive agent. So the first important thing to understand, what is a competitive agent. So agents that compete for limited resources or outcomes is a competitive agent. So behavior is each agent maximizes its own utility, no information sharing. So the real life examples here are online ad bidding, real-time bidding. Okay, so multiple advertisement agents. So they actually bid to show their ad. So you have seen ads in Google, Facebook, Instagram, right? So that is basically a multiple advertising agents. So the next thing is only one wins the auction to display the ad to the user. So already that is actually a bidding actually done for the by the companies. So agents are optimized to smartly bid for cost-effective ad placement. Next is mixed motive agents. So these are basically operative in environments where cooperation and competition are both required. So it's basically a combination of both. First one, cooperative, and the competitive. So that is why we are calling it as a mixed motive. So the behavior is it uses the strategies from game theory to balance the interests. So the examples here is stock trading bots. So bots may collaborate in sharing market sentiment, example like the news signals, but ultimately compete to buy low and sell high before others do. Next, agents may even form temporary alliances like the flash mobs to influence the market trends. Now, let us go to the architecture part. Okay, so let us try and understand the architecture. So there are three kinds of architectures. Okay, so the first one is the centralized, distributed, and the hybrid architecture. Now let us try and understand that what are the architectures involved in the multi-agent system. So the first one is the centralized architecture. So the definition for the centralized architecture basically is the central agent which controls everything in a simple way to understand. So easier to manage, simpler logic, global view. Okay. And the cons, the biggest con is the single point of failure. Because if something in the center fails, so the entire thing actually collapses. So that is the biggest issue with the centralized architecture. So a real life example is traffic control system or center. One control unit manages all signal agents at intersections. So signals adjust based on the traffic. So if you have seen these centralized architectures, now this is actually a failure mechanism coming to the real part. That is why these AI signals, what you're seeing, they are not basically a centralized architecture. Because if something in the center fails, everything collapses. So they are not using these kinds of architectures now. Before it was like that, but now it is not used. So here you can see one particular application where I've just used it. Okay. So this is an example of how the traffic management. I'll come here. Okay, I'll just come here. So this is one example of how a traffic management is done. Okay, so the AI signals, okay, controlling everything. Okay, so based upon the kind of traffic is there, the signals will communicate with each other. So since the signals are communicating with each other, it becomes a multi-agent system. Okay, it becomes a multi-agent system. So the next thing is, this is how traffic is actually managed, all right, by the AI systems. So it will try to identify that people, people, vehicles, and all. So based on that, it will try to adjust. Okay, yeah. Now, before going into the distributed, this one I left off. I just wanted to tell you this. Now, here, if you see, this is basically an example of an AWS cloud. Okay, so AWS cloud, Amazon Web Services, cloud services. So here you can see one example where user actually writes a query. Okay, so it is actually divided into multiple things. So it uses different kinds of agents. Okay, so here it is using three kinds of agents. So one is the native agent, one is the open source agent, the other is the proprietary agent. Okay, so in the proprietary agent, there is one thing which is Crew AI agent. And the native agent also, there is one which is the Bedrock agent. And coming to the open source agent, there are three, which is the search agent, LangChain agent, and the RAG agent. So in that, again, if something, something has to be processed, if something matches, right, it has to use, again, it has to come back to the open source agent. So, or, processing the open source agent, it is going to process the loop and it is going to add, or I would say answer your queries or searches. So that is what, how it is going to do. So, but the Crew AI agent, this is basically a image generator. So something which is a yes will generate the image. Something it is no, it goes back to the, again, the loop to go to the to the query part. For example, it might be again an open source agent. Okay. Right. So, yeah. So let us go to the next one. Yeah, this one is done. Yeah. So smart home example, you are already aware of actually, correct now. So here you can see that consumer is basically using a PC. From there, it is connected with the smart appliances, right? And in that, all the it is automatically constructed, or sorry, it is basically controlled by a particular gateway. Okay, so this particular gateway controls through internet that all the necessary point of control, right? So it is how it is going to process. Yeah. So next is the distributed architecture. Okay. So next is the distributed architecture. So distributed architecture is what is very, you know, lot more safer, I would say, lot more safer, because this is basically highly scalable and robust to failure. So there are very less chances of failure because the systems, or we would say the it is not just single point of control. Okay, so they are independent agents, but the problem is communication between the agents. So the communication becomes a bit of tough because there are a lot of agents at multiple places. So the main drawback is basically with this kinds of thing is communication failures. So communication failures can happen if you are using a distributed architecture. There's a high chance that communication failure can occur. Okay. So one of the best examples is you would have used BitTorrent, uTorrent, right? So this is a classical example of a distributed architecture, right? So BitTorrent, uTorrent you would have used for downloading movies, games, right? So this is basically the nodes are connected from multiple points. Okay, there is no one central repository which is actually uh, connecting all the where the data is actually transferred. So it is basically not having a single repository. So it is actually done from multiple places. So for example, even a one particular server goes down also, the file transfer doesn't actually stop. Okay, so it actually maybe the peers might go down, but a few things, but usually the services will not stop because it is not a centralized architecture, but it is a distributed architecture. Next example is the hybrid architecture. Okay, so for a hybrid architecture, it is basically combining the both kinds of architecture. One is the centralized, and the other is the distributed one. So what are the pros is balanced control and flexibility. And the cons are still partially vulnerable to center points of failure. So there is a high chance of failure as well. Let's have a question. Okay, sure. You can ask me, no issues. Architecture means, yeah, this one, centralized. So yeah, I just gone to that, no? So first one, it was the centralized architecture, yeah. So which controls from the center, something which can be controlled from the center. Okay. Okay, fine. So yeah, that's what, something which can be controlled from the center. Okay. So at different, I would say, in a simple way to understand, this is not completely ruled out. This is something where at a certain scenarios it is used. Okay. So before, they used to use this at a traffic control systems. But now I would say, with the AI implementation, a few are using centralized architecture, but I would say, more it is basically a distributed architecture now. Okay. So one example I thought of telling is this, peer-to-peer file transfer, particularly, an application called BitTorrent. So this actually helps you, because this is not a centralized architecture. So that is why I've just given you that example, because you might have used BitTorrent. So those who have used, might be knowing, okay, what I'm talking. Or else, if you have never used, probably this might be a tough example to digest. So next thing is the hybrid architecture. So hybrid architecture is basically, the real life example for this is the smart grid. So this basically uses a distributed as well as a centralized architecture. So basically it has a control center, but still all the AI agents have their own way of communicating with each other, and they have that ability to interact with each other and actually take a decision. So they are basically controlled as well as they can do on their own. So this tells you that this is basically a centralized as well as a distributed architecture. So both are there inside the hybrid architecture. So the pros are balanced control and flexibility, and cons are still partially vulnerable to center points of failure. So everything comes also with its cons as well, right? So that we need to understand also. So this is an example of a smart grid powering the AI systems. Okay, so this one here, I like the picture so much. This is how the AI, powers the smart grids. So this is one more example of how AI can power a smart grid. Okay. Yeah, these two images are basically that. Okay. So why I put this image, even though I've just mentioned here, here you can see that how this AI actually, powers the smart grids, right? So the entire aspect, right, from the, smart power plant, smart transport, smart houses, uh, then we have solar powered points, all right? So these are actually transforming the entire way of how these AI systems are functioning currently, right? So it is a very, very interesting way, because a lot of people are using solar with also the, IoT devices along with the AI. So these are actually transforming the way how the artificial intelligence can be actually used into our real day-to-day life. Okay, so let us see the applications for this. So the first one is the smart grids, which you have seen. Then you have the autonomous vehicles. Then we have the healthcare systems, e-commerce and auctions. Then we have disaster responses. Now let us see each example in detail. So the first one is the smart grids. So you're already aware of the smart grids, how they perform, right? So what are the agents in the smart grid? They are sensors, smart meters, control systems. All are AI agents inside the smart grids. Then the goal is balance power supply and demand in real time. So example is when a region's power demand spikes, agents reroute the power from from other sources automatically to avoid the blackouts. Okay. So the next thing is autonomous vehicles. So each vehicle, traffic lights, road sensors. Right. So these are the agents which are involved. So the goal is safe and efficient travel without human intervention. So example is vehicle to vehicle communication allows cars to perform platoons, optimize fuel usage, and prevention of collisions. So these are the main features of using the multi agent systems. Okay, so going to the next examples, healthcare systems and the e-commerce and auctions. So here you can see that the agents are the doctor bots, patient monitoring agents, diagnostic tools. Okay. And example of this is, the goal is providing coordinated patient care. This is the main goal. Now, example is a wearable health agent alerts an AI diagnostic agent while scheduling tests via hospital scheduling agent, all without human intervention. So that means, when you have to create, do a test, what are the results, what should we do, what are the suggestions, when you have to again perform something. So all these are basically monitored and are actually taken care of. So the e-commerce and auctions. So here you can see the buyer bots, seller bots, negotiation engines. So these are the three, I would say, bots, or I can say agents inside the e-commerce and auctions. So the goal is basically automated price negotiation and order placement. So the example is Amazon dynamically adjusts product prices based on competitor bots, heavier and market demand. So the next thing is the disaster response. So here the AI agents are the drones, rescue bots, and communication systems. So the goal is to locate the survivors, assess the damage, and deliver the aid. So the examples here are drone map debris, ground bots, rescue trapped people, and all agent coordinate to avoid the duplication or duplicating efforts or entering the dangerous zones. So this is how this disaster response can actually, bots can be used. So next, let us go to the ethical considerations in the AI agents. Okay, so let us see the ethical considerations. So the key issues in the ethical considerations are the autonomy versus control. So who is responsible for autonomous agent decisions, and bias and fairness? So ensuring agents don't propagate or amplify societal biasness. Then the transparency, can users understand how and why agents act? Accountability is very important. Mechanisms to trace and audit agent decisions. So informed consent, especially when agents interact with humans. Okay, so these are some of the key ethical issues. Let's go to the issues. Before that, if you have any questions, you can just post it. So let me just post if you have any questions. So if you have any, you can just ask me. Fine. If you don't have any, I can move forward. I will cover a few things anyway. Tomorrow I have one important implementation. We'll implement, or we'll use the transformers. Okay. Okay. Got one interesting question. Low-level AI will interfere in your work. So this question, I think Professor Doctor, you can see. Okay. So actually, I've answered this question in, I think somebody has also asked me. Probably I will again answer this. So it will not disturb the way humans are performing, but it will transform the way how we are actually working. So, and I've also given one actually sentence stating that we have to co-live, right? I always tell these two people whenever I take sessions on AI. So the si- the situations, I would say, or the how the future will be, many people are concerned about. So it is going to not completely rule out what human being can do. It is going to reshape how we are going to do things in the future, right? So that modification will actually happen. So that we have to keep it in mind before doing something. It's not lift, co-live, I meant. Co-live. Or actually it's like co-live. Yeah. Uh, sir, I agree with you, but that's how world is, sir. So not everything is going to uh,
Students, I think there is an issue with the trainers network. So the time is also done. So we will wind up for the day. We'll meet again by tomorrow at 7 p.m. Okay. I hope you all marked your attendance. I have shared the attendance link once again on the chat. If you missed out to mark an attendance, please mark the attendance. So we will wind up the session for today. Thank you all. Thank you for joining.